Hi, this is Kevin. Welcome to part 3 of my uh, uh, tutorial for the coding assignment for the Severance Chapter 11 coding assignment. In this, Severance Chapter 11 is about regular expressions. And in this third part, we're going to, I think this is the first time we're going to build a module that's going to hold a function, and it's going to be a library module. Okay. Um, uh, we are going to include it in other programs. Okay, so the module itself is sort of like a library module. Okay, and we haven't done this before. It's a, a typical way to set your code up. We've been using modules created by other people, the packages we've been importing or those kinds of things, but we've not created one ourselves. Now, before we get started, I want to bring over from the starters, I want to bring over another module that I created, and you folks have seen it before, um, and I think I showed it to you in class last week in the current semester. And it's called IS430 Unit Test Helpers. And by unit test helpers, I mean these are functions that we should be able to use when we're writing unit testing code to keep us from having to write more verbose code than we would otherwise have to. And these are some of the first doc strings that I've created for a module. Okay, so here we go. We have a multi-line doc string. The top line um, gives gives a short interpretation of what the module does. So this module contains unit testing helper code for use in Kevin Trainer's IS430 course. So you're welcome to use these for the course and forever if you'd like to. Um, this is kind of our homegrown version of a unit testing framework. I mean, there are unit testing frameworks for Python like unit test and PyTest, and it would be nice to have the time to teach those in an introductory course, but we don't. Okay, but you also shouldn't have to write like really long verbose testing code. So this is my compromise. I've given you this helper code so that you can write, you know, professional tests without using a formal unit testing framework. So the second line of a multi-line doc string is supposed to be blank, apparently. Now, here are the constants that I have in this. There's one called a pass, which has a string value. A pass is one called failed, it has a string value of failed. And then there are two functions. One's called assert equal, and the other one is called assert equal float. And that's because when we compare things apart from floats, we expect them to be exactly equal, to consider them to be equal. And this is true of ints and strings and lists and all kinds of things. Okay, but when we get to float values, okay, because of the nature of floating point numbers, two values might be very close together, but because of the anomalies of floating point arithmetic, uh, they might only be off by 1/10,000th, and we might want to consider them equal. So we've got a second um, we've got a second function to compare floats. Okay, and if you go down, we have, as promised, a function called assert equal. It has its own doc string. Okay, because it gets called from outside of the module. That's how we know it should have its own doc string. And again, it's got a one-liner, compares expected and actual values, prints the result, passed or failed, on the console. So this isn't a real sophisticated scheme for unit testing. We're still printing the results on the console. Okay, but it's going to serve us pretty well. Skip the second line. Use this function to compare non-float value objects. Okay, that's how we're going to use it. And then I got these this kind of formatting for the text inside of the doc string. When I opened up a multi-line doc string inside of assert equal, PyCharm put these two parameters, sort of parameter expected, parameter actual, got them from up there, and then it put something here where I could document what the return value was. Okay, now I don't think everybody uses this formatting, but some people do. It's consistent with one of the applications that harvest these doc strings and make up documentation packages. Okay, and I just decided to use it because it's kind of built into PyCharm. So we're saying that the first parameter expected is the expected value. The second one, actual, is the actual value. And the return is none, which is to say we're not returning a value. And the code is pretty easy. If the expected is equal the actual, then we print passed. Else we print failed, and then we print out what the expected was and what the actual was, so that without having to do any further work, we can see on the console what's not agreeing. Okay, and this should help us to test a little faster. Okay, and then assert equal float, similar, but there are three values. Okay, we're passing in the expected value, the actual value, and acceptable error. And typically what I'll do is I'll go, let's say that we're tracking dollars and cents. So we're going to have two decimal digits, right? Well, then I'll say that the acceptable error is like 0.001, 1/1000th. You could make it smaller, okay, but that's what I typically do. So this one says it compares expected and actual values, prints result passed or failed on the console. Okay. And then it goes on to say use this function to compare float value objects. And then it's got three parameters: expected, actual, acceptable error. And acceptable error is documented as a float value that represents the allowable difference that is acceptable between expected and actual values. And again, usually make it a fraction of the significant digit that you have. If you if you're tracking dollars and cents, you might make it 0.001. Okay. And then we also document that it raises some errors. So it says it raises a type error if any of expected, actual, or acceptable error are not float types. So when I wrote this code, I thought, well, I don't want the user of this a code to call this assert equal float with anything other than 3 float values. So if they do, I blow it up. Okay, and then again, I make sure that we're comparing the absolute value of the acceptable error to the absolute value of the actual error, if there is an actual error. Okay, and so that these things are within each other. Okay, so if the absolute value of the difference between the expected and the actual is less than or equal to the absolute value of the acceptable error, then it's going to pass. Otherwise, it's going to fail and it's going to print out the expected, the actual, the acceptable error, and the actual error. Okay? And again, we're going to use these just to do an easier bunch of testing. Okay, so this is I think, one of the first library kind of modules that we've seen. Now we're going to have now we're going to build one together. Okay, and this one is going to be called My Password module because here's what it's going to do. Okay, it's going to take a when the user says, "Oh, I'd like to enter a new password." Okay, well, we want to make sure that it meets our standards. And the kind of standards that you usually get, you need one capital alphabetic, you need one lower alphabetic, you need one special character. You have all those kinds of things. So what this thing is going to do is it's going to be a function in a library module. Okay, and the client code, the code that's actually interacting with the user, it's going to get a candidate password from the user, and it's going to call our function to validate the password, and it's either going to get back a list of errors, okay, things that need to be fixed about the password, or if it gets back an empty list, the password is going to be valid. Okay, so let's create our library module. Okay, new Python file, and we're going to call it My Password module. And again, most teams probably have single word names for modules, but I put the hyphens into these so it's pretty clear to us that we created these ourselves. Okay, these are not things that come from the Python infrastructure or from third parties like the Panda library does. This is our work. Okay. So let's give it a doc string. Okay, so here's what I'm suggesting for the doc string. Okay, again, I guess we don't need that extra blank line, so we can do that. So this is a multi-line doc string. So the first line is a summary, a module for validating a password candidate using the re.search function. Okay, and it has one function, validate password. Okay, and I just put paren here. I don't put the names of the parameters or anything like that. The examples that are around the web for exactly how to format these things are a little sketchy. So I'm getting better at it, but this is not a bad first start. Okay. All right. Now, what's going to come next? Well, let's bring in a couple of more things. Okay. So we need a blank line there. Okay, so we're going to need to do our imports. Okay, and I said that we're going to use the RE module, so we're going to import that. We're also going to, as is typical, it's good practice if you're going to create a library module. It's good practice to also include unit test code, or at least it's going to be good practice for us. Oh, okay. And because we're not using one of the formal unit testing frameworks, we're going to put the unit testing code for our module, for our function, into the main function. Okay, but we'll get there in a minute. Okay, validate a password, and it's got one parameter that it takes, a candidate. Okay, good. What comes next? Well, just like I showed you with that other library module, if we have a function that is going to be called from outside the module, which is what library modules are all about, okay, well, it needs a doc string. Okay, and here's where you get the details about this validate password. So again, it's got a multi-line doc string. Okay, the summary line validates a candidate password for compliance with organizational standards. Okay, then a blank line. Apparently, this helps the programs that harvest this content to create documentation for teams. Okay, so there are various programs that you can run that harvest the doc strings and create formal documentation. Okay, and I got a param and return, and again, I got this as soon as I typed in the triple double quotes and made this a multi-line doc string. PyCharm generated these two. So for param candidate, I said string value is the proposed new password, and then return a list of error message strings. Candidate password is valid when the list is empty. All right, so that's my documentation. And again, this is there for users of this library module to learn how to use the function validate password. Okay. So what kind of rules are we going to have? Well, before we talk about rules, let's begin with some initialization. Okay, so here's what I say. I'm going to have something called answer. Okay, now this is a word that I use. This is a word that I use from time to time. If I have a function that's going to pass something back, I'll call that thing we're going to pass back. I'll call it answer. I'll call it result. Okay. We can see that we've initialized it to the empty string. Okay. Now, here are the rules that we're going to use. The first one that we're going to use is going to have to do with the length. Okay, so if the length of the candidate password that they passed it is less than 6, then we're going to append on the answer, which is going to be a list of strings, an error message. Password must be at least 6 characters long. Okay, let's look at the next one. This is a pretty typical one that we're going to do. Okay, let's look. Okay, again, so this is the first time that we're using re.search. Okay, we're using a raw string, even though we don't have backslashes in here. It's always a good habit to make your the strings that hold your regular expressions. It's always a good habit for those to be raw strings. Okay. And so we're saying we have a class of character. It's the uppercase A to Z. Okay. And again, we're testing against candidate, and we're saying if not a match. So if we don't have at least one uppercase A to Z, then we're going to append the error. Password must include at least one uppercase letter A to Z. Okay. What other kind of rules can we have? Well, typically we're going to also require that the password include at least one lowercase alphabetic. Okay, so we have a class of a character lowercase A to Z. Okay, that's good. Now, what's the next one that we're going to do? Well, a lot of times these kinds of rules include a requirement that you have a special character. Okay, so we have a list of special characters in this character class. It's not all the special characters. Some of them are not there. For instance, it doesn't include things like the parentheses or the square brackets, which would be kind of potentially confusing in Python. But it does have the other ones, okay? And if our candidate string doesn't contain at least one of these, well, then we're going to say the error message is the password must include at least one special character, and we give a list of the ones that qualify. All right, that's good. And then we have one other kind of rule. Okay, when you're going to do your version of this, I'm going to have you add a couple of rules. But another kind of rule that you get is we don't want any common words. Now, in some organizations, they won't allow you to use curse words. They won't allow you to do anything like that. But typically, words that have to do with classic passwords. So the one that I'm going to have you do here is open sesame. So there's an old story that has to do with, I think, Alibaba and the 40 Thieves or something like that. Probably a European point of view on a Middle Eastern historical story, I guess. So maybe not the most woke example of literature that I could have picked. On the other hand, Open Sesame is a classic password for, I want to open something. So I'm saying here is if the password includes Open Sesame in any case, because I included ignore case, then there's going to be password may not contain the word open sesame in any case. Okay, so that's all of those. Okay, and then what are we going to do? Well, we're going to return answer. That's it. That's it right there. Return answer. Well, I skipped too many lines. There we are. And I've got to do that. Okay. Very good. Okay, so this looks pretty straightforward. We create an empty list, called answer. So if we don't add any errors, it's going to go back as an empty list, and it's going to be counted as valid. And then we checked the length, upper alphabetic, lower alphabetic, special character, and can it contain the word open sesame. And if we pass all those and we don't append their error messages, but if we fail them, then we do. And these are all independent of each other. This is if. It's not if, elif. Okay, so we're going to test all these and we're going to send back all the complaints that we can find at one time. Okay, are we done? No, we're not done. Okay, because we have an opportunity to include unit testing. Okay, and where do we put unit testing? Well, in our class, we're going to put it into main. Okay, now, does everybody do this? No, they don't. The reason that they don't is that they have access to formal unit testing frameworks, and these formal unit testing frameworks have typically for each module that you have a test module. So you have like a shadow group of modules. Okay, and this is the reason why we don't get into this in introductory class. But this is a great way to do unit tests. And here's what we've done. We put right at the beginning of the main, we've printed on the console unit testing output. Okay. And then for each of the unit test cases, we're going to print the name of the case and a description. And then we're going to do a unit test. All right. And then the last thing that we're going to need, of course, is we're going to have a call to main. Now, are we just going to have a call to main? No, we're finally going to see, we're finally going to use what you see a lot of people do all the time in Python, is they have this test at the bottom where they have the call to main, and they say if double underscore name, which Pythonistas say dunder name equal dunder main, well then run main. Okay, and as you probably remember from chapter 7, if we're running this module all by itself, okay, well then it'll run main. Okay, it says, in the case where we are like we are right now, this comparison is going to be true. We're going to run main. So if we've got the module up all by itself and we go to run a test, well, it's going to run the test in main. On the other hand, when we import this to use it, which we're going to do in our next program, well, this is not going to be true when it's imported. So we're not going to run main when this is imported. So we're not going to run the unit test when we import the code. All right. So let's look at the unit test code a little more carefully. Okay. The input password is going to have an upper alphabetic, a lower alphabetic, a special character, and then 456, so we can know how long it is. So in this case, we say test case 1, password meets all criteria. So we're expecting this one to pass. So we say that the expected result is an empty list. The actual result is calling validate a password with this input password. Okay, and now here's how we're going to use these unit testing helpers. We're going to call the function assert equal with the expected result and the actual result. And if you remember, the way those are going to work is if they match, it's just going to print passed. Okay. If they don't, it's going to print failed, and it's going to print the expected and the actual, so we're able to compare them. All right, let's give this a run. Let's run my password module, and here we go. Test case 1 passed. Now, what would it look like if it failed? Okay, so we're expecting it to pass. We're expecting this to be the empty list. Let's fail it. Let's get rid of the uppercase alphabetic. Oh, and then it'll be too short as well. Okay, so let's run this. Okay, and what does the output look like? So it has the name of the test case that printed failed, expected the empty list, actual, here's a list with 2 error messages in it. Oh, that's right. That's pretty good. All right, so let's undo that change. Okay, and that should get back to a test that passes. And there it is. It passed. Okay, so what other test cases would we want for this? Okay, well, we have one where we passed all the criteria. Okay, we need to test a case to make sure that each of these rules are working. Okay, so let's go and add another test case. So I'm going to take this from my already baked version. Okay, I got too many blank lines there. Again, we're in main, so we can only skip one blank line. Okay, so this one is going to test password too short. So what is interesting here, and this is, I've been using an example like this now for about 4 or 5 years, and if we trigger too many errors with our test case, we'll think that we're only getting one error message, and we'll be actually getting 2 or 3 or 4. Okay, so not only do you have to be able to get, the error that you're looking for, but you have to be sure if you are comparing that to what actually it came back from validate password, that you're not getting more error messages than you put down as your expected. So here it looks like we have an uppercase alphabetic, a lowercase alphabetic, a special character. The only problem that we should have is it's only 5 characters long. Okay, so the expected result is a list with the message in it from that rule. Okay, so let's run this again, and you'll see we passed the test case with password too short. So let me tell you 2 things that can go wrong with this, so that you're ready. Okay. One problem that you can have is you can accidentally get too many errors. Okay. Let's leave out the special character and see what happens. Okay. We left out the special character. We run the test again, and we failed. Why? Well, because we expected to have 1 error message, and we got 2. Oh, yeah, well, that makes sense. All right, let's put our special character back, and let's run that test again. And now we're passing. What else can go wrong? Okay, here's a classic thing that goes wrong when you're testing this kind of code. Okay, you need these error messages to match exactly the messages that are up here. What happens if you're off by just 1 character? Okay, what happens if you accidentally put, sorry, let me undo that. Okay, what happens if you accidentally put uppercase X right at the end? Okay, are they going to match? No, they're not. So let's run a test again. Okay, can you see how they're off by 1 character? That's not good. All right, so this is a potential problem. Now, here's the thing that I'm seeing. I think that we ought to come back here, and we're going to want to make sure that these print 1 under each other. I thought I had them like that once, but apparently I don't. So actual error, now that's not the one. Where is it? Expected, actual, oh, it's up here. let's get these things right under each other. That's going to look better. All right, so that's saved. Now let's come back here and let's run this again. And now they're right underneath each other. So now that was my design for this, and I somehow lost that. But when you have these things right underneath each other, you can go, I have an extra X. Okay, how do you solve this kind of problem? The way you solve this kind of problem is you copy one to the other, okay? What I would do is I would say, oh yeah, okay, let me go up and find the message that's in the real code, okay? And let's come down here and put it in the test code, okay? And now click off of that line and test again, and now we passed. Okay, so the two things that can go wrong here are that you have too many error messages, or you might have even predicted the right one, but you've got the text of the message and you're off by a character or two or a word. You've maybe paraphrased it. Okay. Okay. So let's see. We've got test case for everything passes. We've got a test case for we fail on too short. What's next? Well, missing uppercase alphabetic. Okay, so let's do this. Test case 3, password missing uppercase letter. Okay. And as you can see, we don't have an uppercase letter, but we do have a special character, and we are 6 long. Okay. All right. Let's give this a test. So this is test case 3. Password missing uppercase letter. Passed. Okay. And now we're going to do a lowercase letter. That'll be test case 4. Okay. All right. Password missing lowercase letter. And again, we have an uppercase A and a special character, but no lowercase alphabetic. Okay, so this is test case 4. And that passes. Okay. Now, what about the special character? Let's make sure that we can catch that. Right? And I got my blank lines backwards. Okay. So here, yeah, we have an upper and a lowercase alphabetic, but no special character. All right. So and this is test case 5. And that passed. Okay. And now the last rule that we had, okay, is it can't contain the word open sesame, which of course is a phrase and not a word. But can you imagine somebody putting it in as a password? I can. So we have upper and lowercase alphabetics. We have a special character. And then we have open sesame in mixed case. Okay. We're expecting to be able to find it. Let's run this test. This is test 6. Yeah, we passed that one. Now, are we done? Okay. We've got one test where we passed the criteria. Okay. then we're able to catch all the errors. We're able to prove that we'll catch the errors. The one thing that we haven't officially tested yet is what if we've got more than one error? Okay, will it bring them all back? Well, we're going to need to test that. And that's going to take a little bit of work to construct that. So in test case 7, password missing multiple of the criteria. So here's what we do. We just have it be 1, 2, 3, 4, 5 long. Okay, so that means it's short. So it's going to get the short error. It doesn't have a lowercase alphabetic, so it's going to get the alphabetic it's going to get a lowercase alphabetic error, an uppercase alphabetic error, a special character error. And then what I can do is I can make each of those messages an individual variable, and then I can build the expected result of a list including those 4 variables. Okay. And then, of course, the actual is going to be calling validate password with the input password, and we're expecting them to be equal, right? So let's give it a run. And it passes. Okay. Now, what would it look like if we were missing 1? Well, let's just take out 4. And see if it would get caught. It does get caught, okay? And again, because we made these equal, because we got these one under the other, you can kind of go out here and go, oh, yeah, the first 3 were fine, okay, but the actual had a 4th error message that we weren't expecting. And then if we go back up there and go, okay, let's put that back and let's run that again. Well, that's going to be a pass. Okay, so this is a kind of testing that you would do on a library module, right? It's very professional to not only have a unit test, but to save the unit test, okay? And if you're not using one of the professional unit testing frameworks like unit test or PyTest, well, this kind of approach that we're taking in our class, where you put the unit tests into the main for the library module, and of course at the bottom you do this test, so you're only going to run the main if, in fact, you're running a unit test. Okay, so I'm going to send you off to work on your own on yours. Now, you're going to have a couple of more rules. Okay? They're not real different than the rules that we have, but you're going to have to add some rules to this. All right, so I'm just going to say bye until next time. Bye-bye.